You know that AI revolution that we are all living through? Well, it all runs on this hidden infrastructure that's facing a truly massive trillion-dollar scaling challenge. The data centers that are the backbone of our digital world are being pushed to their absolute breaking point. And the way we used to build them, yeah, that's just not going to cut it anymore. So here's what we're going to get into in this explainer. First, we'll look at the sheer scale of this AI data boom. Then we'll dig into the 4 huge roadblocks that are holding it all back. After that, we'll explore how the industry is learning to build smarter, not harder. And finally, we'll see how this all adds up to a $250 billion opportunity. Okay, let's kick things off with the scale of this boom. And when I say the scale is huge, I mean the numbers behind the demand are they're truly mind-boggling. Okay, get ready for this. By 2030, we're talking about a projected global spend of $1.7 trillion. And that's just on data center infrastructure. And get this, that number doesn't even include the cost of all the computer hardware that goes inside. Now, all that infrastructure, it needs power, a lot of power. By that same year, 2030, the worldwide power demand for data centers is expected to hit 220 gigawatts. To put that into perspective for you, that's not just a big number. That is literally more power than entire countries use. So what does that mean for, the planet's power grid? It means that by 2030, data centers alone are on track to gulp down 4% of every bit of electricity generated on Earth. And look, we've got to be clear, this isn't just about servers for websites anymore. We are talking about the absolute bedrock, the fundamental infrastructure that supports everything from the AI tools you might use every day to real-time financial analytics and, yeah, even the development of self-driving cars. Just look at how fast things have changed. Before 2020, a big data center campus, we're talking tens of megawatts, okay? Fast forward to right now, and just in the US, the demand has exploded to 25 gigawatts. By 2030, that's expected to triple. We are basically entering a whole new era, the gigawatt scale campus. It's a completely new ballgame. So you can see where this is going, right? This kind of explosive growth means you can't just keep doing what you've always done. The industry is slamming into 4 major walls that make the old approach pretty much impossible at this new scale. So what are they? Well, first, just finding enough power. Second, what do you do with all the insane heat that power creates? Third, finding enough skilled people to actually build these things. And fourth, just getting your hands on the parts you need in time. And this first one, power, it's easily the biggest showstopper. You can have the land, you can have the money, but if you can't plug the thing in, you can't build. It's that simple. Traditional power grids were never, ever designed for this kind of load, and getting the upgrades needed can take years. We're talking serious delays. Okay, so let's say you get the power, but all that electricity, it doesn't just vanish, right? It turns into an incredible amount of heat, and that creates the second major crisis. These new AI servers, they run so ridiculously hot that the old school method, just blasting them with cold air, it's just not working anymore. It's becoming totally obsolete. So what happens? The whole industry is being forced into this massive shift over to brand new liquid-based cooling systems. And that, of course, brings a whole new world of complex engineering problems. And it doesn't stop there. Building one of these gigawatt-scale campuses requires thousands of skilled construction workers on site at the same time. That puts a crazy strain on a labor pool that's already stretched super thin. On top of that, you have to get the actual parts. We're talking about critical stuff like giant generators and transformers. The lead times on these things are already incredibly long, and the supply chain just cannot keep up with this demand explosion. And if you want to see just how broken the old way of thinking is, check this out. If you just tried to scale up a traditional design, a single 1 gigawatt campus would need something like 290 diesel generators just for backup power. Can you even imagine the cost, the complexity? It's just completely nuts, totally unsustainable. Okay, so these roadblocks are really forcing the industry's hand. You can't just work harder, you have to work smarter. And that has led to a whole new blueprint for the future, and it really centers around a few key innovations. So what's the big idea here? It's a fundamental shift away from these one-off, custom-designed facilities that are built from scratch, piece by piece, right on site. The new model? It's much more like a modern factory. It's all about standardized designs, much smarter backups that cover the whole campus, and building huge chunks of the facility somewhere else and then bringing them in. The magic here is really in creating these scalable, repeatable designs. The goal is to get 60 to 80% of the design to be totally standard, something you can use anywhere it's built.
This lets you buy equipment in bulk, it slashes supply chain risk, and it makes the planning phase go way, way faster. Then you only have to customize that last little bit for the specific location.
So let me paint a picture of the old way. Let's say you have 5 buildings on a campus. Each and every one of those buildings would have its own complete set of backup power and cooling. You just end up stacking layers and layers of redundancy. It's massive overkill and a huge waste of money.
Now, the smart way to do it is to think of the entire campus as one single integrated system. Instead of every building for itself, you share those backup resources across all the buildings. All of a sudden, the design is way more efficient. It costs less, and honestly, it's even more reliable at this insane gigascale.
Now, to tackle that cooling crisis we talked about, builders have to make a really big long-term bet on one of 3 main liquid cooling technologies. And it is not an easy choice, right? Do you pick a hybrid system like RDHX, or do you go with the most popular kit on the block, direct-to-chip, which has the bonus of being able to be retrofitted? Or do you go all in? Go with liquid immersion. It's the most efficient, but it's also the most radical. You're literally dunking your servers in fluid. It's a huge decision that's going to define the entire facility for decades to come.
Okay, so after all this hard work and innovation, what's the payoff? Well, the financial reason for adopting these new, smarter ways of doing things is it's absolutely massive. Remember that $1.7 trillion price tag we talked about? Well, by building faster and smarter, the industry could save up to 250 times billion dollars of that. I mean, this isn't just tweaking the numbers. This is a fundamental change to the economics of how we build the future of the internet.
And hey, it's not just about the money. These smarter strategies also shave off up to 20% from project delivery times. And in a race like this, a race to power the next wave of AI, being faster is a massive, massive competitive advantage. So the blueprint is there. We know how to do this, how to build bigger, faster, and cheaper. But the thing is, the demand is growing like crazy right now. So the real question, the one that everything hinges on, is this. Can the industry actually transform itself and build fast enough to keep the engine of AI running?